and ensure safe maneuvering on the road. There are various types of steering systems, each with its own unique components and working mechanisms. Understanding how these systems work can help you diagnose and fix any issues you may be experiencing with your vehicle's steering. So, how does steering work? At the most basic level, a steering system is designed to translate the rotational force of the steering wheel into the movement of your front wheels. This is achievable through several mechanisms depending on the type of steering system. Now, let me show you how your car's steering system saves you effort. This steering wheel here is about 15 inches wide or 380 millimeters in diameter, standard size. When you turn it from full right to left, that's 4 full rotations. The edge of the steering wheel travels nearly 16 feet or 5 meters in total. But during that same motion, the front wheels of your car, the road wheels, only turn enough to move the tire edge about 12 inches, or 300 millimeters. That's a big difference in motion. The steering system is designed to trade distance for force. That means your steering input is being multiplied. If you tried to push the road wheel yourself, you'd need around 16 times more strength. But thanks to gears and levers inside your steering system, it feels effortless. They also ensure that when cornering, the inner front wheel, which has to travel around a tighter curve than the outer one, becomes more sharply angled. Your average car or truck likely utilizes a rack and pinion steering system. This simple system is made up of 2 main parts. The rack, a horizontal piece of metal with teeth along the top side, and the pinion gear, a round gear at the end of the steering shaft that interlocks with the teeth of the rack. This is the most common type of steering system used in modern vehicles. When a driver turns the steering wheel, the pinion rotates, engages the rack, and moves it left or right based on the driver's input. The rack connects to the wheels via tie rods and adjusts the wheel angle relative to the car's body. When the rack moves left or right, it pushes the tie rod, leading to the wheel being steered in the desired direction. Consider a driver making a right turn. He rotates the steering wheel clockwise. The pinion gear will rotate correspondingly, pushing the rack gear to the right. The tie rod will transfer the motion to the steering knuckles, which pivot the front wheel and turn them to the right. The number of teeth on the pinion gear will have an impact on your steering as well. Fewer teeth will make it easier to turn the steering wheel, but will require more rotations to complete a sharp turn. More teeth will give you a quicker sharp turn, but will require a bit more strength to complete. This type of steering system is highly efficient, easy to maintain, and provides precise control over the vehicle's direction. BMW was one of the first manufacturers to adopt rack and pinion steering systems in the 1930s, with many other European manufacturers following suit. Auto manufacturers in the United States began to use rack and pinion steering with the Ford Pinto in 1974. As mentioned, many modern vehicles that make use of rack and pinion steering will also be paired with a power steering system. This pairing is known as power-assisted rack and pinion steering. This system includes a cylinder and piston located on the rack. The piston is connected to power steering lines on both sides. The lines provide a pathway for power steering fluid to be delivered from a power steering pump located outside of the rack. As you turn your steering wheel, a rotary valve on the power steering pump directs more power steering fluid to that particular side of the piston, which helps ease the steering. When driving in a straight line, the rotary valve will ensure equal amounts of pressure on both sides of the piston. More advanced systems may vary the amount of fluid pressure based on additional factors, such as vehicle speed, turning force, or vehicle load. As a result of the power assist, you are able to turn easier when driving at low speeds, such as when parking, and have greater control when traveling at highway speeds. Older designs use 2 main principles: the worm and sector design and the screw and nut. Both types were enhanced by reducing the friction. For screw and nut, it is the recirculating ball mechanism, which is still found on some trucks and SUVs today. The recirculating ball system accomplishes the same tasks as the rack and pinion system with some key differences. Instead of teeth, the recirculating ball system utilizes a worm gear, a long spiral similar to that of a bolt. This system still has a steering shaft that turns as you rotate the steering wheel, only that the shaft now turns the worm gear instead of a pinion. The worm gear is inserted inside of a metal box with teeth in it. The teeth of the metal block then transfer the motion to a sector gear, a gear which has teeth on only one side. The sector gear then turns a lever known as the pitman arm, which attaches itself to the steering linkage. This linkage is made up of inner and outer tie rods that are connected to the spindles, which complete the turning motion. Inside of the metal block exists many tiny ball bearings. The ball bearings reduce friction between the worm gear and the teeth, as well as eliminate the slack between the bolts and threads. This is where the name recirculating ball comes from. While this type of steering system is less precise than rack and pinion or power steering systems, it is durable and can handle heavy loads. Here are some notable vehicles known for using recirculating ball steering: Jaguar Mark 9, Alvis TE21, Nissan 280ZX, BMW E39 540i, Jeep Wrangler, Ineos Grenadier, and Lada Niva. In the ever-evolving world of automotive engineering, technology has drastically transformed vehicles over the last few decades. Among the numerous advancements that have significantly improved the driving experience is power steering. This critical system not only enhances maneuverability but also increases safety for drivers. So, how it works? At its core, power steering is a mechanical system designed to assist drivers in steering their vehicles with minimal effort. Before the advent of power steering, most vehicles were equipped with non-assisted steering, requiring significant physical strength to maneuver, particularly in tight spaces or during parking. The introduction of power steering marked a pivotal change, allowing for easier handling and improved driver comfort. The history of power steering can be traced back to 1951, when the Chrysler Imperial became the first production car to feature this innovative technology. The immediate benefits were apparent, as drivers found that they could steer with much less effort. This marked the beginning of a new era in automotive design. The two main types are hydraulic power steering and electric power steering. Hydraulic power steering uses a hydraulic pump driven by the engine, providing pressurized fluid to assist steering. A control valve directs the fluid to either side of a piston attached to the steering rack, helping turn the wheels. Conversely, the electric power steering system replaces the hydraulic pump with an electric motor controlled by sensors and an electronic control unit. As a result, the electric motor provides precise torque assistance. Additionally, it is adaptable to driving conditions and speed. Hydraulic power steering assists drivers in steering a vehicle by using pressurized hydraulic fluid to amplify the force applied to the steering wheel. It relies on a pump driven by the engine to generate the hydraulic pressure, which is then used to move a piston in a cylinder, assisting the steering mechanism. It has a cylinder, pump, and a set of valves to control the hydraulic fluid going through them. The pressure is applied through the pump and is driven by a belt that connects to the engine. The pump speed regulates the speed of the engine. Many modern vehicles come equipped with power steering systems, which use hydraulic pressure to make steering easier and more convenient. When the driver turns the steering wheel, this motion is transferred through the steering column. The pinion gear, which is connected to the steering rack, receives this motion. As the steering wheel turns, it also activates the control valve located in the steering gear, usually integrated with the rack and pinion. The control valve detects the direction of the turn and directs the pressurized hydraulic fluid to the correct side of the steering mechanism, left or right, to assist the turn. This hydraulic assistance is bidirectional, meaning it works whether you're turning left or right, ensuring that the system provides help in both directions. The pressurized fluid flows into a steering cylinder, usually attached to the steering rack. Inside the cylinder, there is a piston that moves when the fluid enters under pressure. The pressure from the fluid pushes the piston, which in turn helps move the steering rack with much less effort from the driver. This hydraulic assistance makes the steering much lighter, especially at low speeds, and significantly